Welcome Algebra 2. This video is for week 2, dividing polynomials. The essential question is, how is using the box method to divide polynomials similar to using the box method to multiply polynomials? Let's begin. So let's multiply this one right here, binomial times a trinomial. Just a little bit of review. I'm going to write x squared, 5x, and plus 1 on the top, and the binomial on the right side, and go 2x and positive 5. So multiplying columns and rows, x squared times 2x is 2x cubed. 5x times 2x is 10x squared. 1 times 2x is 2x. 1 times 5 is 5. 5x times 5 is 25x. And x squared times 5 is 5x squared. Combining the diagonals here, that's going to be 2x cubed coming out for that one. This one's 10x squared, and 5x squared is 15x squared. And 25x and 2x combines to 27x. And then 5 just comes out to 5. So my final answer, writing that as together, would be 2x cubed plus 15x squared plus 27x plus 5. All right, now let's look at this a little differently. Let's say if we want to divide that answer that we got last time by the binomial, we're going to get the trinomial. So 2x cubed plus 15x plus 27x plus 5 divided by that 2x plus 5, you get the binomial. And this is very similar like when you're doing this with numbers. So if I said 11 times 12 is 132, 132 divided by 12, you'd get 11, because it's that relationship between multiplying and dividing. So we can use that same relationship when we're trying to divide polynomials. So let's do this. Let's divide a polynomial, and we're going to use the box method here. So sorry if this doesn't fit on the screen, but I'm going to make it work. So I'm dividing this polynomial on top, which is the answer, divided by 2x plus 5. So you're working backwards that we used from the box. So what I'm going to do is this answer here, the numerator, I'm gonna write it in these diagonals. I already made a 2 by 3 box. So it's a 2x cubed, and it's going to be 15x squared, 27x, and positive 5. And I know my binomial is 2x plus 5, so I'm going to put that on the right-hand side, 2x and positive 5. Now, the goal here is to figure out what goes on top for the trinomial. What are our three terms? Well, we know the properties with the box is multiply the column times the row, right? And we know we're fitting in something in diagonals. This whole diagonal has to be 2x plus 3. This one has to add up to 15x squared. Well, because we know this diagonal is 2x plus 3 and there's only one box, I can put a 2x cubed there. And using a little bit of division, 2x cubed, if this is 2x, 2x times something have to equal 2x cubed. Another way of writing that is 2x cubed divided by 2x has to equal what we put on top. And what's that going to be? Well, that's going to be x squared. So on top here, x squared times 2x has to equal 2x cubed, so it has to be x squared on top. Now that I know that, I could start filling in on the bottom. X squared times 5 is going to be 5x squared. And what's neat is since this is 5x squared and this has to add up to 15x, well, just subtract and you know that this box has to be 10x squared. And if you have 10x squared right here, divided by 2x, so I can write this as 10x squared, and it's got to be divided by 2x, well, I know the trinomial right up here is going to be 5x. And if that's 5x and that's 5, this is 25x. And since it's 27 on this diagonal, this is 2x. And since this is 2x, 2x divided by something is 2x, and that's got to be 1, because 2x divided by 1 equals 2x. Or another way to write that, to be consistent, 2x divided by 2x equals 1. And then if that's 1 right there, this has to be 5. So now my answer, dividing that polynomial by 2x plus 5, is just the top up there. X squared plus 5x plus 1. And I'll write that over here on the side. X squared plus 5x plus 1. So we're just going backwards with multiplying binomials using the box method. That's why I stressed doing that yesterday or last week. So let's try this again. Now we have to create the box this time. I didn't just give it to you, but what's the dimensions of the box? Well, we know we're dividing by a binomial, so I'm going to have 2 rows here. So I'm going to draw 2 rows. Then you might say, oh, how do I know how many columns I'm going to have here? Basically, your answer is going to be 1 less than the number of terms. So since I have 4 terms here, I'm going to have 3 columns. So 3, that's not really, even enough. So let's put those in. And I'll use red again. And so this is going to be 2x cubed. Going in this diagonal is going to be x squared. Going in on this diagonal is going to be negative 16x. And going in right here is going to be positive 15. And I know on the left-hand side, my numbers are going to be, or to right-hand side, 2x and negative 3. So let's fill in. For this first box up here, 2x cubed divided by 2x. I know I'm going to have this 2x, or 2x times what is that? I know this has to be x squared. So, excuse me, that's x squared, and not up here. So x squared times 2x is going to be 2x cubed, because I know this had to be 2x cubed, because there's only one option. Now this next one, so if that's x cubed, x squared, and that's negative 3, this will be negative 3x. If this is positive 1x squared minus 3x, well, in this diagonal, we have to have positive 4x to fill that out, because 4 minus 3 is 1. So if that's 4x and divided by 2x, I'm going to get 2 up here. Our 2... Oh, this should have been squared. So this should be 2x up here. And 2x times negative 3 is negative 6x. Now, if that's negative 16, negative 6 minus another 10x is going to be negative 16. And if that's negative 10x divided by 2x is negative 5. And negative 5 times negative 3, positive 15, which is my only option. So my final answer is this trinomial on top. So x squared plus 2x minus 5. And that's how you divide polynomials. All right, that's going to be it for today. Stop the video.